This prototype is a fault-tolerant series-resonant DC-DC converter. This is my main AC main which I am giving to the rectifier. This AC converted to DC. This is my main input voltage DC over here. And this DC has been given to the inverter setup. This is the inverter. This is the gate drive for the inverter, and this is the microcontroller to activate the inverter. The inverter, the purpose of inverter, it converts DC to AC. So this AC has been given to this rectifier. This AC has been converted to DC. This is my main output. And these are the switches which works in open loop condition, and this is of closed loop condition. So let us explain the kit when it is in on mode. Now my circuit has been turned on. The first condition is it is in open loop condition. Let us see the output voltage over here. When I am turned on, there is no fault occurred over here. The pulses are not shorted, and the inverter works in full bridge mode, and I get an output. Now when I am making a fault to occur, I am offing. We can see a 0 over here, which means a fault has been occurred over here. The gate pulses are shorted. Now in order to overcome this fault, I am using the closed loop mode. When I turn on this closed loop, my fault has been recovered and we can produce an output. You can see this in multimeter. Now let us see this in oscilloscope. Now my kit is in open loop condition where there is no fault. So I am generating a pulse over here. So my output is. So I am getting an output. Now when the condition where the fault occurs, you can see there is no generation of pulse over here, as well as my output is 0. Now when I turn on the closed loop, my fault recovers a generation of pulse over here, as well as I get an output in my multimeter.